Hello, everyone. Welcome to the CDF webinar workshop. It's a new series that we're doing, continuous delivery workshops. And I'm joined today by Thomas, one of the co-chairs, and Saim and Steve. And I'll let Thomas introduce the workshops to you.
Yes, hello. My name is Thomas. I'm one of the chairs of the workshop committee together with Veronica Martini. And yes, we are trying to give you some more knowledge about continuous delivery and related technologies. And yes, I think today is the first session, and I'm very excited about what's coming today. And with this, I think we can start, and I will hand over to Saim.
Thank you very much, everyone who are listening to us from around the globe, wherever you are, on the YouTube or on the Zoom chat. Thank you very much for joining this session today. So my name is Saim Safdar. I am a CDF Foundation Ambassador of 2022. And now let me give you the insight, what we are covering today. In this CDF workshop, Steve Taylor will cover 5 phases of the DevOps process that must be enforced to improve your supply chain security. In this workshop, you will learn about new open source security tooling that you can immediately add to your pipeline to implement good security practices. And you will learn along the way what phases of the pipeline need security action, how to implement OpenSSF security scorecard, where signing and SBOM generation should be added, how to understand SLSA, and how the Parsia decentralized package network help you achieve SALSA compliance, and how to use Ortelius as an evidence store to consolidate security logs and build an organization level security profile, and how CD event will simplify adding new tool to your pipeline to maintain a secure software supply chain. So without any further delay, let me hand over to Steve itself, and all of us monitoring in the chat. I'm going to leave the chat. If you join us on Zoom, you have a Q&A section. There you can add all the questions, and I will actually throw those questions to Steve as we see them on the Zoom or YouTube as well. With that, I'll hand it over to Steve. Steve, can you introduce yourself and start the proceeding of the session today?
Hey, everybody. Just wait for the slides to load here. So I am Steve Taylor. I am the CTO of Deploy Hub and one of the architects for Ortelius. So let's go ahead and dive into what we have going on. So today we're going to take a look at how security needs to be applied to our supply chain. And when we talk about our supply chain, that I equate to basically the CI/CD pipeline. So you'll hear me use the words interchangeably between supply chain and pipeline. So that's what we're going to be focusing on today. One of the things that we need to recognize is securing our software is complex. And some of the reasons why it is complex is just the nature of the beast with our software. Our software is being looked at as one of our points that we can be attacked through. So initially it used to be like going after a router, denial of service, those type of things. But the hackers have found that the supply chain is an easy way to get malicious software into the code base and then out into runtime environments. So just in the last year, according to Sonatype, we've had a growth of over 700% in malicious supply chain attacks. So instead of people attacking like endpoints as routers, they're actually going into the supply chain and making the attacks there. Another statistic that we have is boards, the C-level execs are now finally considering that cybersecurity is a business risk. Before they were kind of just ignoring it. They could get by. We're not gonna ever be attacked. Somebody doesn't care about us. to attack our platform. But as we're seeing where pipeline software is being, oil pipeline software is being attacked, to everyday websites are being attacked, and causing massive outages as part of the process. So, I mean, we just had one this past week with the Move It, I believe it was JS code, that enabled an attack plane for folks to get into your software. And finally, overall, companies are seeing between the 65 and 80% increase in the visibility of what's happening with their application security. And this is part of the part that we're going to take a look at. So we're going to be spanning not only the supply chain visibility, but also what's happening into your application level security. So today we're going to cover the new tools, some new phases that we need to add to our pipeline that are all needed to secure our software. There are a lot of tools out there and vendors. We're going to be focusing on ones that are focused around the Linux Foundation. So OpenSSF tools, CD Foundation tools, CNCF, mainly open source tools. This is not the exhaustive list or the only way to do things. This is just pulling, because we just don't have enough time. I could talk on this for days and days. So we're going to break down what we have available out of those organizations and see how we can apply them to our pipeline. And then finally, we're going to really take a look at, after we put all this in place, what does it get us? What can we prove to people what we've done? So from the CD Foundation side, some of the open source tools that are out there, we have Jenkins, Tekton. Google Cloud Build technically isn't a project running under the CD Foundation, but Google is a CDF member, so we've included them. Ortelius, Persia, and JFrog. JFrog is just like Google. Frogbot is not necessarily a CDF project, but JFrog is a CDF member. So we're going to dive into each one of these and take a look what we need to do and how we can leverage them in our pipeline. From the OpenSSF side, there is the OpenSSF security scorecard. That is a GitHub action that kind of scores, we'll get into it, about a dozen different items to give you a grade on how well you're securing your supply chain. Then Salsa, salsa.dev. It really isn't a product, but it is more of a process and methodology that should be followed. Also from the SigStore cosign, the SigStore project, there's a few other underlying projects that are out there besides cosign. There is like Malenge, AppCo, ChainGuard, a bunch of projects that kind of fall underneath that, the SigStore world. Then SPDX, that is the SBOM, one of the SBOM formats that we can utilize and pass data around. OpenSSF also has what's the vulnerability database called osv.dev. That one's interesting because it actually goes out and collects vulnerabilities from multiple sources and kind of aggregates them together. So it's basically, I think of it as a one-stop shop for looking for vulnerabilities when you need to look something up. And then finally, at the bottom, we have SIFT. This is just one of the SBOM tools that are out there that is part of the OpenSSF as a member company. I believe SIFT actually technically is in the CNCF side. So on the CNCF side, other projects that are out there, Artifact Hub for storing your artifacts, such as your Docker images. That will also give you some ability to scan and get a security vulnerability scored. Another one on the Docker side is BuildX. So BuildX is a toolkit that allows you to do extra type of processing when you do your Docker builds. Obviously Docker Hub, Quay, which is on the Red Hat side, and Trivy, which is a security scan tool. Trivy is one of those that you can plug into your like your GitHub Actions. So obviously GitHub from Microsoft, they have a bunch of tools that are kind of built into the platform. We are going to be talking, there will be a lot of discussion around the GitHub side because a lot of the open source projects in the Linux Foundation use GitHub as the repo. This does not mean that like GitLab, Bitbucket, any of the others are excluded from this, just that we're going to be focusing on more of a slant around GitHub because of what they've done so far. So some of the products on the GitHub side that they're kind of already built into the platform. You have CodeQL, Dependabot. GPG necessarily isn't a GitHub product, but it is integrated into the GitHub for verification and signing. Another thing that we need to look at is going to be your signed off by, your actions, and Microsoft has another SBOM tool. Like I said, we're going to be just hopping around here, and this is not going to be like the all-inclusive definitive list. So just take what fits into your situation. So one of the things we're going to take a look at in our process for application security is I've actually broken out the pipeline into 5 phases around how we need to secure the pipeline. So this is not your typical dev test, your build or your dev test release model that we normally see. This is going to be the points at which we need to add security steps into our whole pipeline. So the first step is going to be when we're looking at our coding. When we actually do our coding and our commits, there's going to be a whole pre-commit process that we want to do security scanning, that type of stuff. So that's what we're going to call our phase 1 code and pre-build. Next, we get into our build process. Now, our build process is where we actually are going to create our artifact, whether it's going to be a Docker image, or we're going to create a Golang program or a Rust program. That's going to be that process of the build. You can think of it as the old term, the compile process. And then based on the language and what we have going on in the build phase, we may or may not need a post-build phase. And we'll get into why we need that post-build phase. And that's mainly because of the tools that we're running in the build phase don't produce SBOMs. So we have to do a second step to grab and generate the SBOM at that level. And we'll dive all into this in a second here. And then finally, we have a publish step. So that's where we're going to take our artifact and publish that out to our registry for people to start consuming. And then our last phase is what I call the audit. How are we going to audit everything from phase 1 all the way through, what's happening in our auditing, so we can actually see and verify what's happened. And some of this comes into play like with Tecton chains. There's some other tools that are allowing us to kind of create this immutable audit of what's happened through the pipeline process. So our phase 1, like I was saying, coding and our pre-build. So this is where we want to look at being able to take our source code and our Git commits and being able to add some additional information about who we are to the commit. So some of the things that we have at that level is the signing piece. So Git natively has built into it the ability to do signing. And that's based on the GPG keys that you have to generate. So the GPG keys, they kind of are like your business card. You can think of it. Who am I to the world? And basically you generate your GPG key on your own. You provide the information and you upload that information. One of the things with GitHub is you can upload your GPG key, and that will allow for verified signing to be like tagged on the commit. I'll show you that in a second. It's not a perfect. There's ways to spoof GPG keys and stuff like that, but it's one of the first steps to let the people, the world know who you are making this commit. And all the major Git providers support this. So GitHub has it, GitLab, Bitbucket, all of them have an ability to associate the code signing to that. Now, one of the things that happens on the code signing is, don't get confused, because there's code signing, which is the GPG keys, and then there's a signed off by. And a signed off by is basically a comment, a formatted tag in the commit message saying signed off by Steve Taylor, for example. Projects, some open source projects require that to be there, because it's basically saying, yes, this is my GPG key, and then this is my like well-known name, my real name that's part of the commit. Some of the projects will actually reject your commits if you don't have both of those turned on. And when you're looking at the documentation for Git, it's a little confusing, because I'd have to actually go look this up again. But one is when you do your Git commit, there's a lowercase s, so dash lowercase s will, I believe, do the Git commit signing with your GPG key. And then the same thing, a dash with a capital S will add the signed off by. Now, there's ways to configure aliases or a pre-commit hook to be able to automate that. There is a debate out there whether you should do the signed off by automatically, or if you have to type it in. Because I have mine, so every commit I make it has my signed off by signature on there. Because I'm not going to all of a sudden not sign off on a single commit. We'll go through and do our PRs and all of our commits. I just want to make sure I don't miss anything, and I'm the one doing it. So that's going to happen on that front. So when you look at the Git help, don't get confused by the lowercase s and the uppercase s for the commit and the signed off by. And there's links in this document on that will be posted that you'll be able to follow to get to the right places to get the documentation on how to implement the aliases and the pre-commits. So that's kind of on your Git commit signing. Other things that we have at this phase are the source code analysis. So the SCA tool, that's going to be checking how your code looks, and actually going through and parsing your code and looking at your code quality is a good way to describe it. So there's a couple open source tools out there, Veracode and SonarQube. There's many other SCA tools out there, like JFrog has one. There's a bunch, but these are the ones that are kind of fitting into the three organizations I was talking about earlier. So that's going to give you the software composition analysis is going to give you that insight into how your source code is actually pulled together. That's a little bit different than your package dependencies and your SBOMs. These tools can also kick out SBOMs, so the software bill of material report, as well as looking at vulnerabilities in your code base as well. So that's kind of like at the lower level. If you need, like I said, if you need more details about all the tools out there, go out and check out the OWASP link here for the tools that give you the SCA. On the other side, once we get our code into our from our local Git repository to more of the public side or the hosted side, so we actually push our commits over to GitHub. GitHub has the ability to kick in a few other tools as part of your GitHub actions and their security plugins. CodeQL is another vulnerability scanner that will look at your code base. So that actually does a repo scan. Now, one of the things like CodeQL will do, and the same thing with Trivy, they'll look to make sure you didn't throw secrets into your Git repo by accident. So it'll actually flag ways, if you have a secret out there, you don't want your secrets, even if they're like even for test cases, or test repositories or whatever, you want to keep your repository clean of any private information. So CodeQL and Trivy are good ones to add into those. And a lot of these, like CodeQL and Trivy, are just checkboxes in the GitHub world. So it's super simple to be able to just turn them on, do some basic configuration. I think by default, if I remember correctly, CodeQL will run on a schedule. And same thing like with Dependabot. A lot of these are on a weekly schedule. I change the schedule to daily, just to keep our code base, because we have so many commits happening to our repositories. We actually want things to be checked more frequently and keep up and kind of head off any security vulnerabilities that may pop up. So in the security world, a week is a long time. You want to be reacting to these things in hours, if not a day at the most. Dependabot is another tool on the GitHub side. Basically, you can actually run this outside of outside of GitHub. It's a little more difficult to run standalone. But the idea behind it is it goes out and takes your, let's say we're in Golang. We have our Golang mod file and our Golang, I believe it's some file. Those two files kind of list our dependencies, and Dependabot will come along, look at those files and compare the versions that you're running of all your package dependencies to the repositories to see if a new one was released. So on that front, we want to go ahead and keep up to date with the most current versions of our package dependencies, and the main reason around that is because those are actually getting fixes. So we want to keep everything as current as possible. The Dependabot will look at all the different languages, whether you're running a Node.js, a Python, Rust, like I said, Golang, Java, Docker. Also, I believe it would go into Helm charts and stuff like that to make sure everything is up to date. Now, what it'll do is you can configure that a couple different ways. Most of the ways I've seen it set up is you tell Dependabot, go ahead and create a PR for me, and I can then review the PR to see if I want to make those changes. Otherwise, I can take that PR branch and check it out and run my tests locally to make sure that that bumping those versions are not going to break anything. One of the things we did with Ortelius is we actually have Dependabot set up, and we actually, we have a couple different methodologies. We have one project team in Australia where they've implemented another GitHub action to go through and automatically approve all the PRs. So they just have it on a schedule. Another sub project that we have I'm running just a shell script that uses the GitHub command line to list all the PRs, and then I can go through and approve it through the command line that way. And another sub project is doing the same thing with the shell script, looking for the PRs and then approving them manually. One of the things we have run into with the Dependabot is sometimes it'll jump from like 1.5 of a package, and then there'll be a new release which will be like 2.0, and that big of a jump kind of messes up when things stop working. So that's where you actually have to do some level of review to make sure that you're good to go. Now, if you have automated testing in place, so on your PR for the Dependabot can actually kick off a workflow that would go through, build everything, and then run your test cases against that PR branch to make sure everything's good. And then you can do the merge at that level. Otherwise, that build could fail and that test could fail, and then you know that you have a problem. They have to intervene manually. Frogbot is the same way as Dependabot, going out and checking your dependencies, doing your vulnerability scanning to see what's out there at that level. So that's what's happening at our initial code phase. So Simon, do we have any questions out there we need to address right now?
Yes, Steve, there's one question. In my opinion, I don't see the name of the attendee, but here's his question. In my opinion, there should always be a security step in the release deployment. The target environment should verify the signature of the artifact to verify that it comes from the pipeline. In addition, there should be a continuous scanning on the target environment of this artifact signature to validate that the artifact is still the same. How do you see this?
Yep. So that's going to be in the further part of the pipeline release. So that's going to be in after we do the publish into the release phase. So that part of it where you're actually talking about doing the deployment and validating what you're deploying and where it's going to, somebody didn't corrupt that part of it. We'll get to, and we'll talk about that at that level. But yes, I totally agree that you need to put tools in place on that part on the deployment side and runtime environment to continuously make sure that things didn't change without you knowing about it. Any other questions for this phase?
And no, Steve. I will check, continuous check, and I will throw those in.
All right, we're going to dive into phase 2, the build. So at this phase, this is where we're actually doing what I like to think of a compile and package creation. So at this phase, when we're talking about the creating this is all around the whole salsa methodology, making sure that you're on a secure build machine, making sure that you have the right code base that you're pulling in. That type of salsa methodology is where we're talking at the build phase. One of the things that we need to do also at the build phase is we want to generate our software bill of material. So the SBOM is going to be generated at this time. This is the best place to generate your SBOM if you can. Now, not all the languages and all the compilers are able to do that yet. So if you look at the APCO, APCO is basically building packages from source. So we go through and build our packages for, basically it's based on Alpine. So we're going to take everything from source, compile it, and create our SBOM. Now the reason why this is important is we're actually at this point taking the source code, compiling it, and we're generating the SBOM of the source code that was used to create the binary or the package at that point. So we have a source to package SBOM. And we'll see how that's different than a post-build SBOM that we're going to get to in the next phase. And one of the neat things about AppCo is if you have a package-to-package dependency, the way it's set up is all the SBOMs are available for all your package dependencies as well. So basically, when you go down the tree and get to your lowest level, the most independent package, that SBOM is going to be, the source code to that that artifact, that package. And then if I have a consuming one, that consuming one will have its source code plus the source code of the package that it depends upon. So it starts nesting all of these SBOMs together. That gives you a really nice picture of source code to binary artifact at that point. So that's like your best case, because you get a lot of details. You get the git commits of the source code. You get a lot of information. Also, if things are being signed, AppCo can actually do signing as well. So we'll get into your co-signing methodology, Notary 2. Those type of things will also happen through that level of detail. So that's your best case scenario is you have a language set that has the compiler or packager actually generating a source to package SBOM and doing the signature. So that's gonna be like your ultimate dream SBOM that you want to try to achieve. On the Docker side, BuildX does something similar. It is able to do the bring things in, generate the SBOM as it's going through and creating all the layers, letting you know where things are coming from. But it's going to give you, because it's a Docker build, it is going to give you the layers, basically the packages that were installed in the layers to the image that you're creating. So that's the different level of SBOM. That's package to image to package SBOM. You're not going to have the source code going all the way back to depending on the packages that you're bringing in. If you're able to bring in some of the AppCo packages, so ChainGuard has a Wolfie image that you're able to consume, and then you could build upon the Wolfie. So you're going to be able to get some of that source code SBOM, but if you're using like an Ubuntu or a Debian base image, or even an Alpine base image for your Docker, you're going to be missing the source to artifact or package at that level. So this is where things are getting better, but that's what you want to really achieve, is you want to really have the compiler doing the work. Now, this is a mystery to me. Why over since these compilers were created, like the GCC compilers created 25 years ago, why GCC at that point just didn't have automatically kick out an SBOM for you, even if it wasn't an agreed upon format. If they could have been at least kicking out the source code and a shot of the source code and what you created, that would have been nice. But that's really where it needs to go to get you a really detailed SBOM at that level. The Perseus side, Perseus is a distributed build network. So you actually take the same source code and you build it on 5 different machines, or 5 different companies at 5 different machines, and you come to a consensus whether you built all the same source code, you got the same result from the same source code. So that's one of those things that trying to mitigate that SALSA attack plane. And then also another, like I said, some of the other SALSA stuff was the hosted cloud build systems. So you need to have a hosted build system. Building locally on your laptop just doesn't cut it for having a secure process. Anything else on that, Simon, from the Q&A?
No, Steve, no, Steve. Haven't seen anyone, but I will just definitely ping you if I can see it.
All right. So phase 3. So this is where I think today, this is where most people are adding SBOMs into their pipeline. So the SBOMs, because the phase 2, there's a really limited number of compilers or packages that are generating an SBOM for us. We need to do it post creation at that level. So it's kind of the next best thing to get us closer to what's making our software, putting all our software together. So this is where we're going to take like Sift. We'll look at your code base. It could look at a Docker image. Same with the other two. They're basically going to look at post build. Let me go through and try to derive all of your package dependencies and give you, a full list of your dependency tree and all the names, all the plurals, all the resource URLs for all the packages, give you some of the package SHAs, those type of things to give you that package to package dependency SBOM. So when we talk about SBOMs, they're going to be at multiple layers. You're going to have your source to artifact or binary or package SBOM. Then you're going to have package to package SBOM. And then you're going to have image to image SBOM. So if you're in a microservices world, you're going to have multiple microservices that need to be aggregated together, all those SBOMs, all the way up to what we call logical application SBOM. So other SBOMs that we also need to know if we're going to be tracking this world 100% and totally be accurate, we're going to need to know the SBOM of the compiler that was used. We need to know the SBOM of the operating system. We're going to need to know the SBOM of the instructions that are running on the chip for that processor. So there's all these SBOMs that we need to aggregate together, because at the end of the day, and we're nowhere close to it at this point, is we should be able to take all these SBOMs and reverse engineer our artifact from all those SBOMs. So we should be able to look at the SBOM for the build system and say, oh, this is run on the ARM processor versus the Intel processor, because that's going to affect our outcome. So there's all this detail that we need to look at to be able to recreate and kind of justify what we created and create a repeatable build process. So after we go through and we're going through and gathering these SBOMs, and we have our signatures and
Sorry to Steve, just one question came up.
Yeah.
In phase 2 to phase 3, how the tools are able to integrate their individual artifact and make a package? Or these pipelines will generate individual artifact, will deploy to production, or kind of aggregation will help in this phase?
Yeah. So in this pipeline that we're talking about, this is for an individual package. So if you think about it in the Docker world, if we're going to create like a microservice that's going to run in a Docker container, that microservice is going to, let's take a Python microservice. So the Python microservice is going to run inside of a container that's based on Alpine. So you're going to have in that Alpine Python image, you're going to have your Python source code, and you're going to have your package dependencies. So I'm dependent upon Flask. What's some of the other ones? The HTTP package, click package, for example, your XML package parser, XML parser as another package. So those packages are going to be, so if you look at it from the SBOM point of view, we're going to have, for this Docker container, this Docker image, we're going to have our source code is going to be one of our package, is going to be in our SBOM. We're going to have our package to package dependencies. Then we're going to have also dependencies upon like the Python runtime that is running in that container. So we're actually going to have 2 to 3 SBOMs that we're going to pull together for that single microservice. Now that microservice is going to then be used with other microservices. So what we're seeing typically today is an application that's based on the microservice architecture is going to be made up about 100 to 200 microservices. So we're going to have about 200, and this is one of a small to medium microservice type of architecture. So we have about 200 microservices that will aggregate together to create our logical application. Now that's going to happen in a different phase. So each microservice will have its own pipeline that we've been looking at, its own SBOMs, its own security vulnerabilities, its own pipeline. They're going to be all running at different cadences. So that's where we're going to have to keep track and implement this for every single microservice. So it grows really big, really fast, put it that way. Hopefully I answered that question.
Yes, sure. Yes, sure. Anybody, if you have any question related to that topic, feel free to. Yes, Brogov, I think I'm pronouncing your name correctly. It said thank you very much for answering. So go ahead, Steve.
Yep. So this kind of leads into what we just talked about is where do we store all this information? If we're talking about in the microservice world, we have 200 microservices. Now each one of those microservices is going to have its own versions. So we're going to have, especially like with the dependent bot stuff, we'll get 2 or 3 dependent bot updates a day per microservice. So we're actually doing about, we potentially, if we have a full blown application that we're doing 3 dependent bot updates to a day, that means we're doing about 600 releases in one day. We can't keep track of that in our head. So we need to know, we need to push this information somewhere, and that's where we need to store the evidence. So we want to be able to take all the information, aggregate it together, and then be able to make sense out of it. So coming out of your image, your build process and your post-build process, you're going to take your artifact and you're going to publish it somewhere. So you're going to publish it either off to like Artifact Hub, Docker Hub, Quay, Maven Central, NPM, PyPy. These are just some of the examples. Some of these registries, these OCI registries, are being extended to store any type of artifact. So one of the sub projects under Ortelius is Emporus. Emporus is an extension to the OCI registry that allows us to store and search any type of artifact, and that's going to allow us to have a one-stop shop for managing all these artifacts and getting the information about them from there. Now, a lot of these tools, a lot of these registries have built into them CVE scanning. So you could actually get a grade of what your artifact looks like from looking at doing a scan like of your Docker image. Are there any low-level Python updates that need to be applied that are out of date? Those type of vulnerabilities are going to happen. It is just what they're looking at is just a subset of the SBOMs. So more information more SBOMs that you can aggregate together, the better your security investigation can occur. So if you're looking at the SBOMs, if we go all the way back to here, where we have Trivia and CodeQL looking at vulnerability scanning at the source code level, we'll be able to aggregate all that together and see from a high level how things need to be updated. Which piece needs to be updated, which piece is where my vulnerability is coming from. One of the projects I was on, actually was on the Persia project. We were looking at the SBOMs for the Rust dependencies. So Persia is written in Rust, and we actually found that based on all of our SBOM analysis, we found that there was 2 different JSON parsers that were being used. So one developer chose one JSON parser and another developer chose a different JSON parser. So in the same actual piece of code, executable, we have 2 different JSON parsers, and one of them was being flagged for CVE vulnerabilities. So what we actually had to do was look at that SBOM and say, oh, we already have another JSON parser that we're using. Let's just throw away or get rid of the one that is a CVE vulnerabilities, make some coding changes, and we'll have a single JSON parser that we're now utilizing. Now, what that does is it does 2 things. First, we solve our vulnerability issue. We're not consuming code that has vulnerabilities. And second, we're making our dependency tree smaller. So the fewer dependencies that you have, the better off you're going to be in the long run as well. So you want to trim down your dependency tree where you can, where it's possible on that front. One of the things that we do after we publish things and we have our evidence catalog, we want to go ahead and cross-reference our SBOMs, because the SBOM is going to give us a list of all our package names and our package dependencies, all our source code dependencies, and be able to cross-reference those to our CVE databases. Now, right now, a lot of these CVE databases are based on packages and the vulnerabilities in packages. We will be getting to a point where there will be a code snippet that could have a vulnerability. So as we're looking through our source code and our source code dependencies and our SBOM at that level, we'll actually be getting to a SBOM that's going to be a commit-based SBOM. So if somebody goes in and adds 3 lines of code that is a hack that opens up a vulnerability in our code base, that commit's going to be actually going to be flagged in the CVE databases. So coming down the road, we'll be actually looking at commit or code snippet based vulnerabilities as well as package vulnerabilities. So just to keep your heads up, and that's where our SBOMs way back here at the build phase are going to have to get a lot smarter and give us a lot more information. So we have a ways to go, but we got to get there. We got to get started and improve as we go. It's just going to be the typical developer process. We iterate and get better as we go. So finally, after we have everything kind of gathered together, we need to be able to do something with this. So one of the things that that somebody mentioned earlier was, are we aggregating together everything at the build pipeline, or what's happening where? So when we look at the different microservices, like I said, they each have their own SBOM, their own CVE, their own impact, their own blast radius, their own inventory, and we need to look at each one of those those pipelines, and from there we need to aggregate all that up together and then look at it from a high level view, so the whole log4j, log4shell issue. How many of these microservices are consuming log4j? How many of these have the move it package as a dependency? Which applications are going to be affected? Is it an internal application, is it an external application, a customer facing type of thing, or public facing? So with all that, we have to get away from having the data trapped in all these pipelines, and we have to get it published and into the evidence catalog so we can then do reporting upon it. Just generating an SBOM in your pipeline and having the SBOM sit there in the build directory, it's a waste of your time. It's not gonna, you're gonna do a lot of work. You're gonna get this file, you're gonna say, look, we got an SBOM, but nobody's ever gonna look at it. Nobody's gonna act upon it. And it's data that has to be reviewed and acted upon. So we have to take it and publish it up so we have a nice, good picture of what's happening from our SBOM at a high level, SBOM of every single dependency, the CVE for every single package dependency. What's happening for different releases that are going out? Is the one that's running in UAT all of a sudden flagged with CVEs, but we have the one coming up from QA that's going to fix that. So instead of that one that's in UAT that's ready to go to the production, maybe we just need to hold that one off and let the one that is in QA that fixes the vulnerabilities get caught up in a day or two and then released. So there's all that information we need to gather and act upon. And that's one of the things, being prejudiced about Ortelius. That's what we're doing, is we're federating all that information up into a usable dashboard that people can look at. Now, one of the things that that we want to achieve with Ortelius is federating all these insights, giving us that logical view across applications and clusters. Once we start gathering this data across all these pipelines, and we're estimating several terabytes of data if we look just at the open source world. And if we look at private companies and the amount of data that they're going to be generating, federating all that together is going to give us a nice database or data storage, now I would say a data set that we're going to be able to run ML and AI against. So we'll be able to go through and look at our pipeline data and our SBOMs and all of that and be able to run models against that and say, oh, if we go fix this one package and put some money into this one package and update it and fix the vulnerabilities in this one package, we're going to be able to solve CVEs for 20,000 companies, and be able to do that. So we could really narrow down our bang for our buck type of scenario. So let's take a look at, so like I said, Ortelius is part of the CDF, and we're going to give you that log of visibility. So it's going to be able to publish, consume all that pipeline data, all the supply chain data, the SBOMs, and give you that visibility to make some good decisions. So let's take a look at some of the data that we're going to aggregate together. Your DevOps data, the SCA, the software composition, being able to understand your package dependencies, not just from the package dependencies of an artifact to its dependencies, but across the whole organization. Like I said, the log4j, log4shell example. Being able to version this, seeing whether something is being fixed or not fixed, if it's getting better or worse, being able to look at it from the logical aspect point of view, and then also being able to see how things are changing from the logical aspect point of view. What release is in QA versus production. And then, again, when we move towards the whole microservice architecture, these pipelines expand dramatically. It does simplify on the coding side. Microservices are much easier to code and manage. You don't get as many merge conflicts. You have a single developer working on a single microservice instead of a bunch of people working on the same code base in the monolith. So there's a lot of benefits to microservices, but at the same time, your number of pipelines explode. So we're going to go through and collect the information through the Ortelius CLI. So the basically Ortelius CLI gets added to your pipeline right in the the build or post build phase. Basically, we need the input into the Ortelius is going to be your SBOM. So depending on where your SBOM is created, right after that is where we want to put the Ortelius CLI. And it's going to take that information, upload it into our database and start centralizing and building dependency graphs based on that. So here's an example of an application level SBOM. Over here, we have all the different, in Ortelius, we call them components, a generic term for an artifact, binary, Docker image. So we take that component, we aggregate the components together, the version of the component into a version of the application. So in this case, this application that we have has multiple vulnerabilities that are found in it. And we can also then do the search on who's using log4j. So let me jump out and we can do this live here real quick. Let me sign in. Just give you a quick look at what we. Now this says deploy hub. Deploy hub hosts the free version of Ortelius out on our Google platform, our Google Kubernetes cluster. So if you want to come play with it, you can sign up for free and give it a go. So looking at some of the components, I just filtered down to one of the ones I know that has some interesting data. So again, some of the data that we're going to be gathering through the Ortelius CLI is going to be like the build. So we know that this version of the component, which happens to be a Docker image, was built on Google Cloud Build. We know the build ID. We know the git commit that it was triggered the build, the repo, which branch it was on, where was the repo coming from. Once the build was completed, this actually got pushed over to Quay with the container digest and tagged with that version there. Some other things that we were able to pick up that need to be basically supplied. We couldn't derive them, but there's a component TOML file that allows us to associate more metadata with the component. So if we have a PagerDuty call down sheet that we want to associate it, what's the developer Slack channel that they use, or if they're using Discord, those type of things are also associated with it. And same thing like with the Helm chart. Is there a Helm chart used? What was the version of the Helm chart that is associated with this deploying this service? Some other things that we're able to grab and consolidate together. What's the README of that repo? Was there any Swagger associated with it? So some of the things that we do when we version this component, we're actually versioning the Swagger information as well. The reason why we do that is if somebody decides to go and change the parameters, we'll be actually able to do a difference and show the differences between the RESTful API endpoints. So developers know, why did something stop working? Well, so such and such went and changed and made this another required parameter to that. Then we have our software bill of material. Now the SBOM here, these packages are being cross-referenced with the OSV dev database. So, and that cross-reference is done live. So right now today, we have no CVEs found for any of the packages that we're consuming. But let's say somebody finds a package in the validation API tomorrow, or the logback core, that we'll get notified that there's a new CVE in that level. The other thing, and I don't know if most people know this, but SBOMs were actually got started because people wanted to know what licenses that were being used in the open source software that you're consuming. So one of the things like with the GNU license is if you are consuming a package that's licensed under the GNU license, there are license interpretations that say that if you're consuming that, you have to now make your source code publicly available. So this is a problem for companies. They didn't want to take their proprietary code base and make it public just because they're consuming a GNU license as a dependency. So that's where actually SBOMs came from. That's where the SPDX was mainly focused on. So we have a bunch of packages out here that have no licenses associated with them. So should we really be using them? You know, where are they? Maybe we need to get on that project team. It looks like they're all from the same, you know, basically repo. Maybe we can go talk to that open source project and ask them to add a license. You know, since they had no license, can we add an MIT or, you know, an Apache license? So going forward, we know what the license constraints are. Then obviously we have the license of our repo, some key value pairs that we may need associated with it. And then we get to look at our package dependency. So this is a graph of this component is being consumed by this one application version. So from there, we'll actually go ahead and package and associate up the data up to the logical application view. So let's go ahead and go into version 10 here, because I think this one has some vulnerabilities. So we can see where we have multiple services. So this kind of gets back to the question earlier about how things are being aggregated together. So when you do your deployment, you're going to deploy either a version of the application. So you can say, I'm going to take all these components and deploy them. Or you could do the reverse. I'm going to go and deploy a component, let's say to a Kubernetes cluster. Post deployment, I'm going to get an event notification that's going to say I just deployed this version. And when we get that event notification, we're going to create a new application version of what that production and deployment looks like, for example. So that's where we kind of are able to do it from pre-deployment or post-deployment at that level. So because we're aggregating together multiple versions of dependencies, we can actually see that we have our cart service is giving us problem because it has a Flask CVE issue that we have to address. So even though we have multiple Python programs that are being utilized, this one is probably lagging behind in a Dependabot update, for example. So all we mainly need to do is to figure out which version that we need to go to, update it and rebuild and create us a new release. Other fun things we can do with the data is we can take the data at the application level and let's go ahead and compare it. So if you ever need to answer that question, what's changed between releases? So we can actually compare. So we're comparing the 91 version versus the 10. And if we scroll down here, we can actually see, oh, somebody added a new Node.js dependency here. And that Node.js dependency, when we have another dependency here, the shipping service got updated. Because of those two things, we have different SBOMs. So at this level, we can see that this is the Node.js SBOM, and that Node.js SBOM this is a simple old world. It brought in a lot of dependencies. And because of that, if we go down here, look through all the dependencies, and get down to our CVEs, we can actually see that the CVE, we have introduced a bunch of CVEs because of that bringing in that Node.js world. The Flask ones haven't been fixed between the two, but that gives you that kind of insight into what's happening at that level. And then the whole question about log4j, very simple. Type in the package you want to look for. This is going to go across all of your applications components and figure out where that's being used. So if I'm interested in this one, I know it's in 2 different components that are affecting 2 different applications. And then finally, we can, whoops, wrong report. Go back over here. We can kind of take a look at a scorecard. This is one of the things that's being built out right now, and we keep on adding more compliance pieces to it, is our compliance scorecard. You know, this is like one of the salsa things. Is there an automatic build happening? Is there, you know, was there swagger present? Was there license present? Number of committers. So this list that we're working on keeps on growing every day, and we actually need help on that front to keep on adding on all the different compliance scorecard pieces that are out there. Let's jump back to our see if it's going to take me where I wanted to go. Come on. There we go. Maybe. Oh. Okay. I have no idea why I can't get back to my. There we go. Okay. So one of the fun things that we're doing on the Artilius side to gather all this data is grabbing it from the pipeline processes and going through our RESTful APIs, and we're actually going to be adding in cloud events as well. From there, we're going to add it to an Orango database that we're going to be using as a push through cache. One of the interesting things is we've been working with the Guac open source team, and they're looking to move their database over to Orango as well for their SBOM analysis. So we're working with the Guac team to do some additional dependency graphing. This is just going to be acting as a cache because of the amount of data. I said terabytes of data. The long-term persistent will be an NFT storage or an OCI registry. In between there, we're going to have a blockchain ledger that kind of lets us record in an immutable fashion all the transactions that have happened. So we have that immutable history of everything that happens for every single version of a component, an application through time. So if you're interested in this, come join the Artilius project. We have some fun stuff going on that front, building this out. And again, just hop on. If you go to the website or the repo, you'll be able to get the links to join the community. So one of the things that, like, when we're looking at that scorecard that we haven't added yet, that's on our list to do, is the Jenkins audit trail. Whoops. And like Tecton chains. So come on. So every time we perform one of these steps, we want to record what happened. We want to get the signature, attestation, all that fun, gory details about who did what, when, where, and how. We want to record and add into the database. So we're going to be leveraging, different technologies. The Jenkins audit trail and Tecton chains are just a couple of them. The CD events as well is something that we'll be utilizing as well. Basically, CD events is going every time you have a different stage that you transition from. So you do your git commit and push, that's going to kick off a cloud event that has a certain payload format that the CD events team has defined, that we know how to go and parse and find the data that we want when we look at that event. So the nice thing with events is we'll be able to add, right now everything's kind of linear, even though you can do like parallel things, and it's all written down in a single file, put it that way, in your Jenkins file, your Google Action file. So the events are going to allow us to be able to interact and add things into our pipeline process without having to go and update thousands of files. We'll be able to just go ahead and add the event listener, and then be able to react to those events when they occur. So we're getting to the end here. One of the other things that we've been working on, we actually did this for one of our repos for the Ortelius project, just to see what we needed to do to clean things up. But we added the OpenSSF scorecard is another GitHub action that you add. And what it does, it gives you a report and a score. It goes through all these different things, looking at how you have your branch protection options set up on your GitHub repo, for example. If you have a code review enabled, and how many people have to review your code. Is it one person or 3 people? All those things affect your security score at that level. So it's interesting. I would pick a project, a repo to implement the scorecard with, and just start watching what's happening and see how you need to change things up to be able to make your score better. Like one of the things that we found that we needed to do was, and it was the easy one, was to use the pinning and the dependent bot. So depending on your deployment, your coding language and your packaging language, you should be able to pin your dependencies to basically to a SHA. And then dependent bot is smart enough to recognize that you're using SHAs versus schematic versions, and it'll actually update the SHAs as well in the dependent bot PRs that it gets created. So pinning dependencies is a good way and an easy one to start securing and locking down your code base. Some of them can be a little more tricky, like fuzzing. Fuzzing is a testing methodology. So that one we haven't been able to implement yet because of the way we have our test cases written. We have to do some more automated testing, add more automated tests so we can then add in fuzzing. So we actually get a bad score on fuzzing, but it's on our to-do list. And this list is going to grow. Like I said, like we initially started, the git commit signing, the git commit signed off by aren't on this list, but I believe they should be at that level. So just a quick review, of the tools that we need to look at. And again, this is just what we've been able to cover today. There's a lot more tools out there. There's a lot of other open source tools, as well as vendors tools that will fit into each one of these kind of buckets. So you want to have your source code scanning. You want to be able to check at that level. Your SCA you need to have at your code and pre-build stage. Then you need to turn on your repository scanning. If you're using GitHub, these are basically free. Just go through and enable them and see what happens. That's going to be, these are the free, easy ones to start securing your software. And the same thing with the git commit signing, git commit signed off by. Your image generation, if you're able to move over from Alpine over to a ChainGar Wolfie image, go ahead and try to make that jump. The AppCo stuff is going to be more challenging because that's going to be around native package dependency builds. really at that level. That's going to be more for people that are creating base images to work from instead of people that are consuming base images. So look at the chain guard base images, the Wolfie ones, and pick your starting point. If you can, move over to Docker BuildX and turn on the SBOM and attestation and signing. The GitHub Actions by default run BuildX. It's the next step of enabling the additional features in the BuildX part of your Docker build. Get over to a hosted build system. Either something on the GitHub side, the Google Cloud build side. AWS has theirs. What's it called? Code Build. Jenkins. Azure has their pipelines. Move over to the hosted build system. That's going to be one of your salsa levels as well. Keep on hitting. Move over to start enabling your signing and attribution and attestation. Providence. A lot of these are going to be, some of these can be tricky because you have to set up keys and public keys and stuff like that. The SIG store and the ChainGuard folks are working on a keyless signature process. So that's going to be coming here shortly. Keep an eye out for that, but start looking into how you can start signing and attesting to what you're doing in your supply chain. Package verification, looking at ways to only pull packages from trusted sources, for example, like Persia. And then if you're not, and this is where most of us are right now, a lot of the SBOM at the build phase isn't there yet. So go ahead and implement your SBOM post build. Get your SBOMs being generated, because that's going to allow you to then cross-reference with your CVEs. So do your SBOMs using, there's a bunch of tools out there, SIFT, SPX, Microsoft SBOM, and then start publishing to either a private registry or a public registry. And make sure on those registries you have the security scan enabled as well. So all these are able to have another level of security scan at that level. You'd be amazed on the number of the timing that happens on who finds securities at what point. Because a lot of the security scans are run in batch mode, so they run overnight. So I will see where things in Artifact Hub I'll get a notification first thing in the morning where something that's happening over in GitHub and Trivy I'm going to find earlier in the day because it's tied to my GitHub Actions whenever I build. So you can get these different timings of things being found, and you want to be able to react quickly to security threat, your security landscape. And then finally, pulling all this data together into the evidence catalog and being able to view it and action upon it. So if you have any questions, you just reach out to me. The easiest way is to join the Ortelius Discord channel, and you'll find me out there. Just drop me a message out there. Otherwise, come over to my LinkedIn or my email is real simple, steve@deployhub.com. So with that, I'm going to turn it back over to you, Simon, if we have any other questions that we need to take care of.
No, thank you very much, Steve, for the wonderful deep dive content on how the security works in the bigger umbrella right now within the different open source tooling we have got. So I think it's been a one super handy session for all of us who are listening to us. So I think currently supply chain security and around a lot of the tooling is built. It's been a very particular the hot area. And as Steve prescribed, we have talked about on today's tool, like we talk about Open SSF, the security foundation who's been able to keep track of all the security related issues. We have to talk about Pythia, and talk about Ortelius, and we talk about CD event and bunch of other open source tool we have got. But if you are interested in talking to how the Ortelius open source project help you in eventualizing aggregating all the data in the one place, So please feel free to join the Discord channel of the Ortelius, where Steve is always there to help all of the answering question if you got. So with that, I will give you I will be reviewing what we have actually covered today, and then I will hand over to the Roxanne to end the session today. And I hope this is the first steps towards more workshop in the CDF for foundation landscape. So today we have learned how the different phases of the pipeline works and how the security action needed to be take place, and how we learned how to implement OpenSSF security scorecard, how to do a salsa, and how the PyTia decentralized package network can help you achieve salsa compliance, and how CD events will notify or simplify adding new tooling to your pipeline to maintain a secure software supply chain. And we also learned how Ortelius as an evidence store to consolidate security logs and builds an organizational level security profile. So securing your organization from cyber hack is not just a job of the production team. It's a job that needed to be take place from day 01 till the end when you release your software into the production system. And it is time for development teams to play their part, and building security with CID pipeline is the first step. This workshop with Steve, I hope, will give you the larger, I have able to grasp the larger CD foundation tooling ecosystem and how different open source tools work together to ease the job of the development team, so they can take security more seriously when they're deployed for their software into the production system. With that, I'm going to thank you very much, Steve, for the wonderful, I think 80-90 minutes helping us understand all the things needed to be for a secured software pipeline. So with that, I will hand over to my colleague, Roxanne, to end this session and let us know when we will be meeting again for the next workshop.
Thank you, Saim. So Saim told me that the slides will be shared, so we'll put them on cd.foundation/workshops. And there will be another workshop. It will be announced soon. We're doing them quarterly. Let us know if you have any feedback about how this first one went. We're welcome to change it up and see what you think. And we look forward to seeing you next time. Thank you, Steve. Thank you, Saim.
Thank you.